Hello and welcome! You have very likely heard about micro-frontends. The basic idea here is to subdivide a huge application into tiny frontends. And now each frontend is implemented by an autarkic team. A team that can work in isolation without the need to coordinate too much with other teams. This shall bring back the agility of small teams, even though you have a huge overall software system. However, now you need to be strong, because I have a bad message for you. Namely, your user. Your user is not interested into micro-frontends. Your user is not interested into starting 50 applications each and every morning. What they want to have is one integrated solution that brings all the features they need. That means you need to collect all your micro-frontends and integrate them into one single page application. I'm calling this single page application the shell or the micro-frontend shell. And this needs to happen at runtime, because everything is compiled separately by different teams. And everything is deployed separately by different teams. So at runtime you need to grab all those moving parts and put them into your shell. In the past, doing something like this, runtime integration, was very difficult. You needed a lot of tricks and workarounds. However, since about a year it is really straightforward. Since about a year you can use Webpack 5 module federation, which really makes this a piece of cake. It allows you to use a dynamic import to load something from over there, from a separately compiled and deployed micro-frontend. Just go with a dynamic import and a mapped path and Bob's your uncle. This, for instance, allows you to load a component from over there, an Angular module, or perhaps just a function. However, if you start dealing with module federation, a lot of advanced questions will come up quite quickly. And this is what this talk is about. In this talk I will cover several advanced questions, advanced topics. For instance, I'm going to start with version mismatches. What happens if you load different micro-frontends and if all those micro-frontends use different versions of the same library? How can we resolve such a conflict? I'm also going to talk about dynamic federation, and I will discuss the advantages and disadvantages of mono and multi-repos for micro-frontends. And finally, I'm going to talk about my good old friend, the Frankenstein monster, about Frankenstein architectures, where you combine different frameworks and/or framework versions. By the way, to get everyone into the boat, I will start with a short primer into module federation. Only 2 or 3 slides. But first of all, let me introduce myself. I am Manfred. I am a trainer and consultant for Angular, and I'm focusing on Angular for enterprise scale applications. I'm doing a lot of trainings and consultancy. And normally I'm doing this on site, but in times like this, you know, because of the pandemic, we are doing all of this remotely, which really works well. Besides this, I'm quite connected to the Angular community. I live in Austria, I do a lot of stuff in Germany, and I'm always happy if I can work together with people around the world, for instance, using remote technologies. Okay, let's get started with the first chapter I've prepared. This is the primer into module federation. As mentioned before, module federation allows you to load something from over there, from a separately compiled application. And for this it defines 2 roles. The first role is the host. In our case, this is our micro-frontend shell. And the second role is the remote. In our case, this is the micro-frontend. You can configure the shell, you can map paths, you can say, well, this path here points over to another micro-frontend that is called this or that over there. Here the path MFE1 points over to another micro-frontend, also called MFE1 over there. And over there you can expose files. You can say, well, let's expose this component or this module, for instance. When doing so, you assign short names to those exposed files. And then everything you need is just a dynamic import pointing over to this micro-frontend and grabbing something from over there. For this, you are going with those map names. That's pretty much everything. One further nice feature of this is you can easily share libraries. Just configure the same library here and there, and it will be shared across your micro-frontends. And this is vital, because you don't want to load Angular, for instance, several times. You just want to load it once and share it across your micro-frontends at runtime. To get started with this, you can use the Angular CLI. However, the Angular CLI hides Webpack and especially the Webpack configuration from us. And so you need a little tiny plugin. For instance, I've written this plugin here, which is extending the CLI for enabling module federation underneath the covers. You can ng edit, then you need to adjust the generated configuration, and then you can serve it. And for this, I've brought a little tiny example. So let's have a look here to my example. This is my shell. This is my micro-frontend. It is located within those red dashed lines. And when clicking there, I'm loading my micro-frontend from over there. How cool is that? I'm loading a separately compiled and deployed micro-frontend. They even run on different origins. The shell runs on localhost 5000, this here runs on localhost 3000. And no, this is not a prerequisite. You can totally deploy everything on the same server, but this proves that I'm loading something that was different, separately, what is this? That was separately compiled and separately deployed. Okay, nice. Of course, if we load different micro-frontends and if we share libraries, we can end up with version mismatches. And the good message is Webpack 5 module federation got you covered. Little side story, because of this, module federation was implemented twice. In beta version, they figured that they need a better story for dealing with mismatches, and so they re-implemented everything. Even the default behavior of module federation is quite smart. The default behavior is it is selecting the highest compatible version, which kind of sounds abstract at the beginning. Let me show you an example. Let's assume we have version 10 on this side and version 10.1 on that side of this or that library. The highest compatible version is 10.1, and so only 10.1 will be loaded by default, 10 will be skipped. Normally, according to semantic versioning, 10.1 should be backwards compatible to 10. Let's assume there is not a thing like a highest compatible version. Let's say we have version 11 here and version 10.1 there. In this case, we have a conflict because a major version might introduce breaking changes. And so the default behavior is to load both. This might be a hit on your bundle size, but it also might be okay-ish. Especially if we talk about stateless libraries. Stateless libraries like rxjs or underscore. Because this part of the application is not worried about that part is using a different version of underscore or rxjs. It's totally fine for both parts. However, if we talk about stateful frameworks like Angular, this is quite a challenge. Because this means you need to bootstrap two versions of Angular side by side in one browser window. And yes, it's doable. The Angular team does not recommend it, but it's doable. However, you need a lot of tricks for it. I will come back to this a bit later when we talk about the Frankenstein architecture. You can even configure your shared libraries as singletons. You know, when you go with a singleton, you have the Highlander principle. Highlander principle means there can only be one. And this means there can only be one version at runtime of this very library. So let's assume there is a conflict. Let's say we have version 11 here and version 10 there, or 10.1. Now, only the highest version is loaded. Even though it does not need to be backwards compatible, only the highest version is loaded and shared. And you will get a warning on the command line. A warning telling you something like this: hey, are you sure you know what you are doing? This might be a huge issue. If you don't just want to have a warning, but a runtime exception, then set strict version to true. This will really give you an exception at runtime. And I really like those exceptions, because such exceptions make your integration tests fail fast. And so you help your integration test to find out that something in here does not really work as intended, that there might be a version mismatch. You can also relax the version requirements. You can say, well, I know this was compiled against version 10, but honestly, I'm an expert. This will work with everything between version 1 and 11. But now here, one more time, you are taking responsibility. If this does not work, it's not the fault of Module Federation. You configure this that way. So as you have seen here, there are several baked-in strategies for dealing with version conflicts. And if everything goes wrong, or if none of those strategies work for you, you can even bootstrap different versions of Angular, even though it is not recommended and you need a lot of workarounds. Okay, let's proceed with the second topic I've prepared. This is about dynamic federation. We have seen before that we need to map paths. We need to map those paths upfront in the Webpack configuration. Paths pointing to different micro-frontends. However, if we have a highly dynamic situation, we don't know those paths upfront. Perhaps we don't even know the number of the micro-frontends upfront. So it would really be nice to get rid of this setting here and to define all those informations at runtime. Besides this, you've seen it on the last slide, sometimes we even need to define some metadata files for our micro-frontends. And this is also nothing I want to hard code in my configurations. This is something I want to configure at runtime with the contents of some configuration files I'm reading or with the contents I'm getting from a backend service. Let's call it a registry service. So at the end of the day, I really want to get rid of this setting here. And that's possible with dynamic federation. However, when going with dynamic federation, you need to replace your dynamic import with a helper function. A helper function using the Webpack Runtime API to load a micro-frontend on demand. This informs Webpack on demand about the micro-frontend and loads it. Funnily, if you compile an application with Webpack, you have several objects in your global namespace at runtime. And this helper function here, I'm written it, you can also download it, is just using those low-level concepts for loading a micro-frontend with just one statement, with one line of code. Of course, here it is broken into 4 or 5 lines. Okay, let's have a look into a demonstration for this. In this demonstration, I'm one more time using this tiny application here, but now it's important to know that this micro-frontend is loaded on runtime. It is discovered at runtime and loaded at runtime. And for this, I want to have a look into my source code. Let's start with the app roots. Those are the roots of the shell. And here you see, I don't have a root for my micro-frontends because the root is created dynamically. I'm creating the root dynamically in my app component. Of course, normally you would move this to a service, but to make everything simple, I've just put this into my app component. In here, you see I'm more or less dynamically creating another route array, an array with some objects describing my routes. And this can also be done in a dynamic way, because at the end of the day, this is just a simple data structure, an array of objects. So you can totally construct this using some dynamic data you fetched from a configuration file. And as you see here, within this dynamically created configuration, I'm using load remote module. It comes from the plugin we've seen before. And here I'm pointing to all the metadata we need to know in order to load the micro-frontend. And as mentioned, this metadata could also come from a configuration file or from a backend service. That's all. After constructing my dynamic routing table, I'm putting it together with the static routes. And then I'm telling the router, hey router, you need to be resetted. Please use this overall routing configuration now. The router can be easily injected into the constructor, as you see here. Yeah, and this allows to create dynamic routes, and I think we all can imagine that it is also quite simple to create those menu items in a dynamic way. So as you see here, this is also quite straightforward. Now let's talk about a huge topic. A topic that was heavily discussed in the past. For some reasons, there is a lot of emotion when it comes to this topic. It's about using a mono-repo or a multi-repo. Honestly, when going by the book, when using micro-frontends by the book, you would go with different repositories. This gives you the highest amount of freedom, because the borders between repositories, for instance, between Git repositories, are quite strict. And that means we cannot easily grab over this border and take something from over there. This decouples everything from each other. And so we have a lot of freedom, like we can use different versions of our libraries or of our frameworks. However, there is also a drawback. This freedom comes with some costs. For instance, now you need to publish your shared code via NPM. And we all know publishing code via NPM can be a pain. You need to version your libraries, you need to publish them, and if there is a bug, you need to fix the bug, version them again, increase the version number, and publish them again. And this is repeated until everything works, or until you go crazy, depending upon what happens first. So as you see here, sharing libraries for project internal purposes via NPM is everything but easy. Also, as mentioned before, you might use different versions everywhere because you have the highest amount of freedom, but this also means you can end up with version mismatches. Angular 11 here, Angular 13 there, what do we use at runtime? If you go, however, with a mono repo, then you have a one version policy. Then you always have the newest version of your shared libraries in there in your repository. You check your changes into the repository, you change it against your main branch, and one more time pops your uncle. That means sharing code is quite easy with a mono repo. However, perhaps you're wondering how to avoid coupling. How to avoid that everything is intermingled with everything else? Because we don't have strict borders anymore, strict borders of our source code repositories. Well, in this case, I would really use linting. For instance, NX brings you a beautiful linting rule that can be configured so that it is not allowed to grab over to another business domain. Here, for instance, I'm trying to grab over to my booking domain, even though I'm in my boarding domain. And so my linting rule tells me, no, Manfred, you are not supposed to do this. Don't couple your business domains, your micro-frontends to each other. As mentioned before, all those goodness is shipped with NX, and NX even brings you more nice features for enterprise scale applications. Let's come to a last point, the Frankenstein solution, or as some people might call it, architectures using multiple frameworks and/or versions. The thing is, we've seen before that we can use module federation to load something from over there via n-dynamic import. So far, we just loaded components and Angular modules. However, if we go one step further, we could also load whole applications, whole single-page applications, and then we could just bootstrap them in the middle of our application. Of course, when bootstrapping a single-page application, we need a root element, but this also could be created with some DOM magic. It's not that beautiful, so let's wrap it away into a helper function. You know, never look into the sausage factory. But now we have another issue, namely somehow we want to route with the Angular router to this single-page application. How can we achieve that? Well, all we need to do is to put everything into a wrapper component, an Angular component that does this for us, and then we can route to this wrapper component at runtime. However, when doing things like this, there are several further advantages, but also challenges. For instance, there is the challenge of bootstrapping Angular side by side in different versions. It's not that easy, but I have some solutions for you. If you look up this library, you will find some of those solutions in an implemented way, and this points to a blog article describing all those workarounds you need for it. However, if you manage to do something like this, you could end up with such a system where you have several versions of the same framework, where you have different frameworks, but also a system where you can share one version of the framework if different parts need the same version. For instance here, the shell and MFE1 share Angular in version X, and MFE2 and 3 share Angular in version Y, and another micro-frontend is using React. Let's have a look into this. For this I've prepared an example in the Azure cloud. It is just a huger version of the example I've used here so far. And as you see here, this is an Angular-based shell. And now I'm just routing to a React-based component or a React-based application. Here I'm routing to a different Angular application. Here I'm using 12.03, while the shell is using 12.00. And because this is a different version, I need to load this version. However, I only need to load it once, because now it can be shared among all the micro-frontends needing the same version of Angular. Here I'm loading a Vue component. So in my point of view, this really shows that we can mix and match different technologies. And here I'm loading an AngularJS application. And I think this also shows that using micro-frontends can be a nice strategy for migrating a huge application to a new tech stack. You can migrate it little by little, domain by domain, micro-frontend by micro-frontend. Because it's that fun, here I have a dashboard using all the frameworks together. Very likely you will avoid a situation like this, but it's also funny to know that it would be possible if you needed something like this. Of course, if you don't need a Frankenstein, don't go with a Frankenstein. Everything else is more straightforward. However, if you need this for the sake of migrating to another stack, or for the sake of merging different applications you've purchased, then it would be possible. You need some enthusiasm and some workarounds. Okay, here you have my ebook. There you can read a bit more about all those topics, and now we can come to the conclusion of all of this. What did we see today? Well, we've seen that dynamic federation is also quite easy because there is this Webpack Runtime API allowing us to configure Webpack at runtime and to load a micro-frontend on demand. We've also talked about the topic of mono-repos versus multi-repos, and we have seen that if we go with a mono-repo, then we are restricting ourselves a bit. But because we are restricting ourselves a bit, we cannot end up with version conflicts that easily. And this shows that restricting yourself can be beneficial. Perhaps you don't even need all the freedom of multi-repos. Furthermore, we've talked about the baked-in strategies for version mismatches, and we've talked about the Frankenstein solution where you bootstrap several single-page applications. And that's it. So thanks for having me. Here you have my contact data. Follow me on Twitter so that we can stay in contact, and have a nice day.